Hello and welcome. So we've got this Marshall SL-X in for repair, JCM900 SL-X, and this amp's been well gigged. It has. It's in red vinyl, as you can see, and I actually notice the logo's broken. There's a few things not quite right with it. One is this preamp control. Whoa. I think we need the foot switch to change channels as well. I'm guessing we need the foot switch. And I haven't got my glasses on at the minute, so yeah, so we've got some issues there. That's the master volume, must be for that channel. Looks like it's got two. That's a volume. Does that say master volume? No, it just says volume. A few issues with that. Well, that pot's either quite dirty inside, or the track's worn at the beginning of it, because obviously with these amps being so loud, it does seem to only be at that in that first, you know, just as you turn it up. So a few issues there. So this, the SL-X one, this has got 5881 output tubes in it. So we're going to crack this out and take a look. Don't know if this has ever been worked on before. It's quite old now, it's from the 90s. So we're going to have a look inside, see what it needs, if it needs any caps, whatever. We'll go on from there, but I think we might be needing a pot by the way that's behaving. Right, we've got this SL-X on the bench. These were made in the early 90s and they're considered to be quite a high gain amplifier. These two channels are controlled by these master volumes, and it makes this amp quite versatile for setting different levels of gain. I imagine you can have a really high gain on one and less gain on the other. You can gauge the channel volumes pretty good, balance them. So it's quite a, supposed to be quite a highly rated Marshall, this one, amongst heavy metal players. 5881 output tubes. Master foot switch, I think, is for those master volumes. You can switch them in and out. I'm not quite sure how that works, but the badge is broken, so we'll probably glue that up. So let's get this turned round and we'll open it up and have a look inside. And just looking at the back, we've got high and low loops level, so the send and return on this, by the look of it, it looks like it can be controlled with that pot there. Recording compensated. Direct, I imagine that's a direct out. Got the impedance selector there. Speaker sockets. Oh, it's got a high and a low mode on there. Interesting. I wonder how that works. We'll have to have a look at the schematic. Two fuses there, both 500 milliamps with. And then we've got the mains fuse there. So you can see in here, these look like the original tubes to me. They look like they've had some long hours on those. And I don't think this amp's ever been opened, you know, in 30 years. It's, I don't know. Although someone may have been, I don't know. Yeah. That's a Siemens tube there. That's a Siemens tube. Oh, that's a bit weird, a bit loose. We'll have to have a look at that, won't we? Not sure what's going on there. Let's try this one. Oh, that one's the same. Maybe it's just the sockets. Maybe it's just the sockets. Let's have a look. He's got no writing on him, so we don't know. If somebody has been in this amp, it's not been in it in a long time. Still got the original the LCR caps. Still got those in. Got that label on there which says this amplifier is fitted with 5881 power tubes. Well, output valves it says, because it's obviously English, not American. And it says replace with the same type only. Right, let's get it out of this case and have a look at the chassis. Right, just got in this amp, my days. So check out this capacitor down here. Look at the dome on that. Looks like the top of my head when I've got my hat off. My word. That is proper domed out. That's done. Without a doubt, that's done. And these are already beginning to bulge. And nasty black gooey stuff that they've got round those. And that seems to be got some more down there. They seem to be the original caps. Now that is 10,000 microfarad. So I'm going to have to order one of those. Don't keep anything like that in stock. Look at that, man. That's the worst I've ever seen. It's amazing that's not exploded. Just let go. that's proper bulged. Those two are done as well, they're bulging slightly. Now when I said I wasn't sure whether anybody had been in this amp before, someone has been in this amp before. And look at this resistor here. If we just go in, that grubby horrible wire wound resistor has just been tacked on, and that needs to go, because that's a right. Some stronger glasses on so we can see that. Yes, that's just been tacked on, and not very well either. So we don't know what that's about. So we are going to need a schematic, because of course we don't know whether that's going to be the correct value, and someone's botched that on. While they were putting that in, they managed to lose one of the screws that holds the chassis in, so we've got to try and hunt down a bolt for it. Those big caps there, they look in good order, but 30 years old. I think they've got to be changed as well. Looking at this on here, this amp's had a lot of hours. Looking at the tubes it has as well. And I'm just trying to go through now and see if I can see anything else on here. I think this amp's really just got to have a full recap. And it's a really nice amp, it deserves a full recap. These amps are mint. At the beginning of the video, when we did a bit of a test of it, we noticed one of these pots wasn't very clever. Now I don't know whether that is just, they just need cleaning, but I kind of suspect that that pot may be worn on the right on the edge of it, on the start of its track. But we'll have to check that. But nothing else jumps out at me. It's just strange why that resistor has been changed. Maybe it was getting hot, and I don't even know that. Is that on the power supply? Must be, being that size. These 5-watt resistors here, I'm guessing that they are on the screens of the output tubes. I'm guessing. And they look in good order. So it's strange why this resistor's been changed, really, because nothing in here, there's no signs that anything's ever, been burned or anything's got hot. These are still pearly white, as as they were when they were new. They don't look like they've ever been changed. So we've got looks like a bridge rectifier here looming, and that is dry jointed, I think. Look at that, how loose that is. So I think we need to look at, obviously this board's got to come out anyway, because we've got to change these caps. We've got some more caps down here which we might as well change while we're here, and we can't see what those are because someone's squirted some gumption on them. Rather black, a nasty black gumption by the look of it. Probably getting a bit loud there, we're getting over the camera. So those LCRs are 50 plus 50 microfarad, so we've got those in stock, but we don't have, we may have some of these smaller ones in stock, but that I know I've definitely not got in stock. I don't even know what part of the circuit that's on. I have to look at the schematic for that. And I don't think we've got these in stock either. I have, but only in axials. And then there's a couple more down there. We're honing these two here, and they are 100 microfarad at 63. We may have some of those that will fit. Right, just looking at this board, nothing's been sprayed. Oh, has something been sprayed on it? Yes, something has. Do you know, and what made me think that is when we looked at at the top. Yeah, that's like oil. Fortunately there's not a lot of it, so we can clean that off. Right, so I think that's a bit of an assessment. You can see in there just as well as I can what's needed there. So we've got to take this board out completely, this front board. The back board, so this back to this resistor on here. This resistor was obviously one of these cement resistors, but because I can tell by where they've cut it, you can still see the original lugs in there. And what I am thinking is, to do that properly, really, we need to take that board out. This oil, now I'm starting to see more of it. So I think someone has sprayed, that looks like the dreaded WD-40 to me. That's something you just never spray into guitar amps. See what fuses we've got in here on this board. Does it tell us what they are? Doesn't appear to, so we'll have to look on the schematic for that. Actually it says 230 volts at 2 amps there. So we'll check those fuses. I think I'm going to check those. I'm going to try and get a schematic downloaded and check those fuses on the schematic. Check the fuses in the back, because we've got 3 more there on the back we need to check. Right, better go and order some parts then. And see what Pink's up to. She's sat at the side of me waiting for some treats. So as you can see, my trusty assistant is here. I've took the knobs off the front, and there's no nuts on these. It's actually, if we look, this board is held in by the look of it with jack sockets, nuts, and there's a screw here, another one there, and another one there, and I think that's all that holds this board in. So we should be able to get that out pretty easily. The other one, obviously there's more work to take that out. We've got the sockets, and we've got, I think the fuse holders will just pull through. So we've got the sockets, and then we've got the mains, the power IEC there bolted in, so we'll have to take those out as well to get that board out, because I don't want to tack onto that resistor. Right, I've just got the camera handheld at the minute, so I've just come in here to change these caps, and I've just been looking at this amp in a bit more detail, and somebody's messed about with these capacitors, because we've got a blank terminal there. That yellow wire there has been moved and was originally on that terminal. The red wire was where the yellow wire was, and then there was a loop across there to parallel that capacitor. That's how I'm reading it on the schematic. So looking at the schematic now, from what we've seen on there, we've got a 50 plus 50 here, and if we look, we've got blue 3 there, and we've got yellow 3 there coming off that capacitor. So if we look at this wire here, that goes up to there, which is blue 3. This yellow wire here, which has been moved from here, from this blank terminal, goes to YM3, YW3, yellow there. So we know that's been moved. So let's go back and look at the schematic again. So now, if we look at the other capacitor here, you can see RD2 there, and you can see that the capacitor's joined across there. There's a link across to parallel that capacitor, and then there's another wire going off down here, and if we follow that wire down and go down to here, that is the center tap of the transformer. What might have happened is this might have blown this half of this capacitor, and maybe that's how this sluggy looking resistors ended up in here. Maybe somehow that resistor got burnt out when maybe that capacitor's gone short or something. I don't know, I've not tested it because I'm taking them out anyway. So we need to wire this back, and if we look again here, we've got that wire going there, and red 2 is there, so we know that's red 2, and we know that shouldn't be wired with the brown wire, although it doesn't say the brown wire on there. I think that brown wire, and you might be able to see it, you might not, that brown wire I think is the center tap of the output transformer, and I can't get to that and I can't see it under the board. So what will give me some idea that that is the center tap is that if I put the meter there, so you should be able to see it. So if the light's not shining on it, you might be able to see it. So if I assume that that is center tap, the brown wire, and if I go onto the plate on this tube, which is there, if we should get a reading for the transformer, and that's 15.2 ohms, because we know that's one side of the transformer. So brown wire is looking like center tap. So if we go to the other side here and we go to there, which is the plate of the other side of the transformer, and you can see again we get 15 ohms. So that tells me that that brown wire on there is center tap, and that red wire should be on the terminal that the yellow wire's on. The yellow wire should be on this terminal here, and that should be linked, those two terminals, brown and red, the brown wire, red wire, they should be linked parallel. And that's a common thing you see on these Marshalls. Now I actually one of the reasons I did it, I typed in Marshall SL-X chassis into Google because I wanted to see if this black gunk was factory or not, if I could see it on any other chassis. It's probably the only way. I have to say I've not worked on one of these amps before, and it does look like it's factory. You can see that on other models. What you could also see is this capacitor blown on quite a few. This must be a common fault with these amps, this 10,000 microfarad capacitor blowing and making this dry jointed. I actually found that fault a couple of times while I was looking. But while I was actually looking to see if this black gunk, this silicon, was there, I also looked to see if these were wired how I thought they were on the schematic, and they are wired exactly as you can see on the schematic. So that has definitely been messed about with. So we're going to put that back to original, and I have spent a few minutes just checking that out and making sure that we're right with that. So this amp is very powerful. It's a 100 watt amp, and messing around with the smoothing on it and wiring it differently is not a good idea. And I'm sure this has worked, they've got away with it or whatever, but it's not right, and we need to put it right. So that's what we're going to do next. We're going to swap these capacitors and make all that wiring correct on there. Right, I've got these caps fitted, and I'm just going to run this amp up and make sure they're running right. We've got them wired up how they should be wired instead of how they was wired before. Yeah, we've got some voltage there. Yeah, that's good. 53 volts on there, 20 volts on the variac. Oh dear, that's pink coming in, and that means we're going to have to shut down the electric if she tries to get on the bench. Go away, Pink, we're busy. Pink's not in my good books at the moment because she tipped a box of tubes over. I got a box of loose tubes that I bought, and Pink tipped them over, and they was all over the kitchen floor, rolling around. Right, it's got a bit more now. So we've got 75 volts on the variac, and we've got 170 volts on the plate. There. There we go, yeah. .78 milliamps on the amp meter. So we're running this up steady because of the capacitors. 259 now, and I've got 120 volts on it, so we should see that begin to draw down. Just turn it up a shade more. Let's just see what we've got on these plates. Oh, they're a bit close together. There's pins on those valves, my word, on those sockets. 278. Aha, we get some. What? Oh, sorry, misread that. I'm getting worried then. Thought how we got more voltage on the preamp tubes than we have on the output tubes, but that's just me being a div again. Yeah, 176. 253, so that's come down, so we can hear a bit of noise. Yeah, we have sound. Let's go up a bit more. So we're at about 150 volts now, and I have on the plate, I have 311. Now we're just checking some of these pots, and this presence control feels very lumpy when you turn it. It is working though. It feels like it's had a bit of a bang. But it is working. It's one of the reasons why I've run this up now before I take these boards out. One is to make sure that we've got the wiring correct on the cab, there's no mistakes, because it's much more difficult when you've done all the amp and then you've got to backtrack. So we'll do it a bit at a time, and then we check as work, go through it, make sure everything's running. So that is working, but doesn't feel very nice. Bass pot, middle, treble. That volume pot's a bit very dodgy, that is. Look at that. I'll just move the camera. So what I'm going to do is I'm going to spray these pots and see if, I think that pot is damaged. The other one I can't test because I think I need the foot switch to do that. No, you're not to get up, sweetheart. So we need to look at that as well. Now the other thing that I actually wanted to look at was this bridge rectifier and see how hot it's getting. Not particularly, is it? I can get in. No. So that's not getting particularly hot. The cap's not. I just really wanted to see that is dry jointed on there, and obviously it's probably got hot to become as dry jointed as it is. It really is loose. I'm surprised that's even connecting. So I just wanted to see if that was heating up, because this is a common fault. I've seen this on the internet, on a couple of forums and things. So I just wanted to check that, because obviously the other reason is to make sure if it is glowing red hot, I don't want to be running this amp for very long, or I should be having to be buying one of those as well. There's a resistor there that looks a little baked as well. I think it's more a case of it's been baked in the past. Now, and our friend the slug, well, he's very cool. Right, so we're just cleaning the last of these pots. And then we'll switch it back on again. See what these pots are like. So I keep catching that camera. I always have it so close to where I'm working. Right. A bit swishy, that one. I think we'll probably have a bit of a solder around on these pots when we get this board out. That one's a bit swishy. Let's 207. No leakage on that capacitor. I'm not sure about these pots, you know. I think that's inside it. I think that's. I think the track's a bit tired in that one. Probably only just see what I'm doing, can't you? There. If I don't find any dry joints under there when I take that pot out, I think I'm going to replace it. And you see, they're not showing any signs when you press the board. Yeah, that pot's had it. So we need a new volume pot. That one's okay. That one we can't test without the foot switch. Well, I presume we can't unless it's got another fault on it. That feels a bit groggy as well. That presence control feels awful. In fact, you can probably hear it grating away. But it still works okay. That diode's getting a bit warmer, but that's still nothing to worry about. So, I just wanted to make sure that weren't glowing red hot while I'm running this amp. It's obviously been red hot at some time, because obviously, as I say, it's dry jointed really badly. And that resistor there, is that a drop-in resistor? Again, without looking on the schematic, but we can check it for voltage. 390, 389. We got on the other side 317. Don't worry, it's only a test speaker. 317. So that is a drop-in resistor, and it's not the most ideal place to have it, is it? Right between those capacitors. Capacitors don't like heat very much, but it's not. 33. Where are we? On there. You can just put the camera back, you can see it. 35. Obviously, you know, when this amp's being rocked out on, that's going to go up a bit more, but it's not excessive. So I bought this because Michael, one of the subscribers to the channel, gave me a telling off for putting my fingers on the components and seeing whether they were hot or not. She says you need to buy a proper temperature gun, so I bought one. So telling off noted. So that's where we are. We've done an assessment. We know we've got those caps replaced. We know we've got to take all this board out anyway, because all these caps are shot. This one's definitely shot. This volume control is also faulty, and we need to replace that. I can't see I might as well just get one and replace it, because I don't want to do all those caps, put this board in, and then we finish up with a faulty pot. The others are fine. A bit swishy on that one, but it could just be that because it's such a high gain amp. I'll check around a few of the I mean, they look like orange drops, those. If we just zoom in there, you can see that's a coupling cap there. I'm just going to check some of the caps, make sure that none of them are leaking. Right, so when I did these temp checks to see if this bridge rectifier was getting hot because of this capacitor, and it wasn't, and obviously it's really loose, I decided I'd take the board out. Well, I've got to take it out anyway and have a look. Are you ready? You ready for this? Check out that mess. Oh my days. And you know, I have a rule of never swearing on this channel, but I tell you what, I'm awfully close with that. So that rectifier's obviously blown at some point, and obviously it's taken off some track. So some idiot has just pushed the wires through and then just tacked it on with these, and so what I mean, despite the fact that it's blatantly untidy, the other problem is, look at these two here. We look in there, let's just get some more light. So if we look in there, and you can see, I'll just get in. This camera doesn't focus too well in when it gets really close, but so if we look, we'll use this. This can just be folded down onto this. These two terminals here, they're almost touching, literally. Now they may be on the same track, so that might not be a problem. I just can't really see whether they are at the minute, but I don't know. But anyway, these can be just crushed down onto here. That's already on its way, folded down, almost touching there. Have you ever seen anything like that? I mean, well, we have, because actually on the Black Star, if you remember, someone had botched up that Black Star HD5, if any of you has watched that on the channel. Yeah, that's just shocking. And now I'm sat here wondering what I'm actually going to do with that. That is just dreadful. Absolutely dreadful. And down here they've been scratching away on this point here if we look in again, and the problem is now the camera's beginning to create a bit of a shadow over this because we're getting in, let me try that. So now if we look, you can see there, they've been scratching away at that as well. I don't know what they've done there. And then the board is badly burned, and they've not bothered to scrape off any of the, you know, the residue. Just pushed the wires through and botched it up like that. So yeah, that is not good. And at this moment in time, I'm kind of looking at that and wondering how we're going to fix that and make that safe. Because it's not like we're going to get another board for this amp, is it? It's 30 years old. So there we are. Billy Bodger has been again. One day, you know, I'll get an amplifier that's just right. I know I like a challenge, but that really is taking the mick. I also think as well that that is a much heavy duty bridge rectifier, because if we look on, and you probably can't see now, but if we look on the PC board, you can see a circle underneath that diode on the board. Now normally if you have that circle, then that's usually the shape of the component, like on all these capacitors and things, you've got a yellow circle around those. It's usually to mark the shape. Hence there, look, if you see, that's a diode there, and you can see the shape. So somebody's put this in more heavy duty. Good idea, badly executed, I'm afraid. Right, we've addressed this diode on the filaments, and I've managed to find the tracks and get this all down flat and instead of how it was before, if you remember. It still looks a damn mess, but it's the best I can do with it, really. At least it's safer now. And all those wires just tied around each other, waiting to make contact with one another, and another big bang. So I've got most of the all the carbon and crap off there with the alcohol, and I've just managed to join onto these tracers, which I don't know why they didn't do that. Furthermore, these scratches up here, look, all of this. But anyway, that's the best we're going to do with that. At least it's much safer now. It just doesn't look very pretty, does it? We've replaced that capacitor as well that was bulging there. So what I'm going to do now is replace these caps, well, all of them, all that's left. And this volume control, let's just hone over here. This volume control is no good, and this presence pot, although it works, is very gritty when you turn it. So I've actually bought a full set of pots for this amp, but I'm going to change those two to start off with. The reason I bought the whole set is that when we get this amp up fully running and we start to test it, we may find some slight faults in these pots. You know, they're 30 years old, so if we find any more, I haven't got to then order again and make it even longer before it gets back to the customer. So just ordered a full set. We know we need at least two, because although that presence is working now, it might not be in a few months time. The way it feels, very gritty, horrible. So that's being changed. This one's being changed. And then if there's any problems with any of the others, it's no big deal to whip this board out. It's only 5 minutes to get it out. So I've got this board capped, let's see over there, and I've got these pots in, so I've put in two volumes because they were a bit cheapy. Put two of the genuine Marshall ones that I've got, and I put a presence control in there. An amendment on those electrolytic capacitors that we installed earlier. First of all, the schematic we had before wasn't the right schematic. That schematic was for the same amp but with EL34s. This amp obviously has 5881s. So those capacitors were wired correctly, except they'd made a change by where they'd removed that one side of that 50+50, the yellow wire, and soldered it onto the spare lug that was left on the capacitor, and I'll show you what I mean with that. So just get a pointer of some description. So you can see the yellow wire there going into the first 50 of that cap, and you can see the blue wire as normal. So what they'd done is they'd moved the yellow wire and put it on this spare node, because we've got this spare node here, and that is, and you can see that originally we had the red wire connected to this wire going here, which is the brown wire, which is the center tap of the output transformer. They should be connected together, so that was correct on there. What wasn't correct really, that they just moved that wire over, and I thought they'd actually been messing around with that. That is the correct way that these caps should be wired up, so I have changed that and amended it. And also on the bias, if we look down here, have we got the bias circuit on this one? We have. So if we look here on the bias, we've also got the 47k pot. We've also got the 47k resistor, which is also correct, although it has been changed on this amp, and they have damaged the tracks doing so on there. So this amp is now back together, and apart from I've been doing a few tests on it, I wired those caps up correctly, and I didn't really, obviously I'd not really looked into biasing this thing or anything. There was so much wrong with it, so many components wanted changing, and changed the caps, fired it up, yeah, it run, just switched it off again, and then carried on working on this amp. But then when I came to bias this amp, I noticed that there was some issues, so I started to delve into it. So the first thing I checked were these two fuses here, and one of them was blown. And how that works on here is that these are a fail-safe fuse. You work off the cathodes down to a diode to ground, and basically if a tube red plates, the fuse blows, but this amp will carry on running as a 50-watt amplifier. And that's exactly what had happened. So when I started trying to bias this amp up, it just all the figures were wrong. Something had to be wrong. So quick investigation found that fuse blown, and obviously I'd got to check the fuses anyway to make sure they were all correct. I'd checked these two on the boards because I was working on the boards, so working my way through it. So I replaced the fuse, and lo and behold, within a few minutes of this running, one of the tube's red plates, which I expected it, to be honest. So I saw it red plate, switched it off, and I managed to find a 5881 and replaced it, and then the amp ran stable. But the amp was running red hot. It was alight. So I did a quick bias check on it, and these tubes were biased at 25 watts, which even at 100% they should only be 23. So obviously at 70% they were miles out. So I set about changing, thought I'd change the bias resistor, which 47k. Now I'm now up to 75k on there, and I've just about got these within a window where they'll work, but the preset's bottomed out. So I think on this amplifier that these 5881s are not the original ones that were put in when this was at the factory, and I think these are the Russian ones, the Softtech ones. These are drawing more current, and you do find that, especially with Russian tubes, you do find that. So we're still in the process of trying to get this amp biased up now. That's where I've got with it so far. And I didn't want to cover the biasing too much in this video because we cover it in a lot of other videos. But as usual, we've found problems with this amplifier. Again, it's, you know, with this. And the thing is to always watch with these, and I've actually seen it on one or two forums, because I did quite a bit of reading up last night on this amp. And there's one or two guys been on, you know, they've posted a questions about why they've got such, you know, low current on the bias. And the reason for that is probably because one of these fuses has blown and they've not realised it, because the amp runs perfectly fine. You wouldn't know, you would not notice unless you were really, you know, unless you were using this amplifier flat out every day, you know, when you were gigging, every time you're gigging, should I say, you wouldn't notice. You would if you were using it flat out, because obviously suddenly you'd have less power than you normally have, and you'd suspect something were wrong. But you don't suspect. There's no hum, there's no nothing. This amp just runs, and it just runs at 50 watts. Why wouldn't it? If you pull out a pair of the tubes, you know, the outside tubes or the inside tubes, it'll run at 50 watts. The impedance won't be correct on the transformer, but the amp will still run fine, which is really what happens when these tubes shut down. It's just like you've pulled them out. So there's no reason to suspect that. It's only when I came to do the bias calculations that I quickly realised something was wrong, and then first thing I go for was the fuses. So we've now got to balance this up. So this was 47k factory. I'm now up to 75k with that, and I've just got these tubes into a window. So they, you know, these tubes, some tubes just draw excessive current more than others do, and that's commonly known amongst Russian tubes. We've demonstrated that on the channel before. So this 10k resistor here, I'm going to reduce it to try and bring this into more of a window, and I'm going to reduce that to 8.2k instead of 10, and that should get me into the window. The problem with this bias preset is that it only has a 2-volt sweep on it, so it makes it really hard to, you know, if you've got like a 5 or a 6-volt sweep, to make it much easier to get this into a window. Because what I don't want to do is leave this, you know, biased up, but I've maxed the pot's bottomed out, because that doesn't, you need, if you're going to do this properly, that pot needs to be roughly centre. You need to have some give either side for it, for, you know, for the next guy that comes and puts some tubes in it. So we need to get that right. Right, so I've got 17 watts roughly, just over 17 watts on each side, and we need 16.1, but the pot is maxed out on there. And the pot doesn't even give me 2 volts, it gives me about 1.8 volt sweep across. So what I'm going to do now, I'm going to shut down, and I'm going to change that resistor there to 8.2k. I'm going to leave this 75 tacked in for the time being. I'm going to tack in an 8.2k, and what I'm going to do is balance this up. So we've got that pot roughly in the centre. I can't see the only thing I can think about that is that's a trim pot between the two tubes. I don't think it is, but I'll have a look on the schematic. And of course, when I've actually measured the bias while I've turned it, and it's increasing or decreasing the negative volts to the grid. So it's obviously biased, but why have it with such a low sweep on it? You know, it really needs about 5 or 6 volts sweep on it. Put the 8.2 in, that got us pretty close to where we want to be, but the pot's still maxed out, so put 6.8k in. Just going to make sure we've got bias voltage while it's on standby. So the thing to remember as well, if you're doing this, if you're tacking in resistors like this on PC boards, is always make sure that you've got the bias on it. Put the amp in standby and check that you've got the negative volts before you switch the standby in. Never assume that you've made a good connection underneath the board. Remember, when we get these correct, we will take the board out and put them in properly. So always check that every time you change a resistor top side, always check the bias before you switch the standby on. Right, we finally got this bias done. A few more bits and bobs to this amp. So we've got 16 watts on this side, exactly about 34 milliamps a tube now, and on this side we've got 15.4. so there's a little bit of discrepancy in those tubes, but not much. 0.6 of a milliamp, that's acceptable. So we've cooled this thing right down. Bearing in mind, at the start the bias was at 25 watts. So we've removed one tube, and I've done some other changes. So that 100 ohm resistor there went open. Whether it was just a faulty one with it being new, it just went open. You switched it on and there was nothing. Tested it, tested the screens straight away, there were no voltage on the screens. So obviously he's the culprit. So what he does is there's no choke on this amplifier. This amplifier doesn't have a choke, so it's got that 100 ohm resistor, which is between the first and second nodes on there. That's what he does. So he's now got a 120 ohms 10 watt resistor in there, a rather tasty resistor. These are some resistors I bought recently. So he's now in place, and I've upgraded the screen resistors, which were 480 ohms to what they normally have on the like they do on the Fender, 470 ohms, sorry, 470 ohms. I've now put, these are 1.8k screen resistors. They've only dropped the screen voltage 4 volts, but again, it just makes this amp run much better. And it's most people upgrade screen resistors to 1k anyway. Some people put them up as much as 2.2. I was going to put these at 1.5, but I only had 1.8, so I put them in. It's minimal. What difference? It doesn't make any difference. So I put 1.8s in there. Marshalls have 1k anyway. Most people upgrade Fenders if they're 470 ohms. They'll put 1k in. So we've upgraded those, and they're 6 watts as opposed to 5 watts. And I think we're pretty much good to go with this now. So a bit more testing, and then I think we're away. So we finished up with the resistors. We had a we had a 47k in there. I've now got a 75k in there, and in this one, which we had to reduce, was 10k, and it's now 5.6k. So we've had to do some reducing and increasing there on the bias, but you do that to the tubes. The problem with this amp is this as I said, this preset only has a sweep of 1.8 volts, so it's not particularly great. So and again, these tubes just draw more current. Some tubes do, and some don't. Just the Russian tubes tend to. These are Soft-X, but we've got this amp running pretty good now. We have got a bit more testing to do, and then we'll be ready to put this on the 4x12. Back with this Marshall, we still had some problems when I came to run it up on the 4x12. So one of the problems was one of the tube sockets was faulty. This amp originally came in for cutting in and out, and it was only when I put it back together, got everything running up and running, discovered that it was the tube socket. So it was 50-50 whether we cured that problem from all the work we've done, and we didn't. So I've replaced that tube socket. I've also replaced the coupling caps from the phase inverter to the power amp tubes, more so as a precaution really, because this amp's 30 years old. Tubes are very expensive now. They weren't leaking, but they're only 400 volts rating, so this amp's been running always, because it had been running at 50 watts for such a long time. It has had quite a high plate voltage on it, so I've changed those as a precaution, because we know how much tubes cost. And the thing with this amp is, now these tubes were good, they were just drawing a lot of current, and just shoving these in this amp, they weren't right for it. But I've made these tubes work properly because they're expensive. To replace these tubes, we're talking for a decent quad of over £200, and that's a lot of money when there's a good set of tubes here which we can do a workaround on and just alter the bias, and that's what we have done. So this amp is now finished. So we're going to do a demo on this amp now.
and I've had a bit of a go on it, and man dingo, this has got some gain on it. I can't remember working on an amp that's got more gain than this, although I've had one or two that's been pretty close. And it's not back in its case yet, and the reason for that is that I'm going to do the demo on this and then test this on the scope and just on a dummy load, and I'm just going to put a sine wave through it, 1 kilohertz, and I'm going to turn this amp up pretty loud, but obviously it'll be on the dummy load for half an hour, just to make doubly sure that these tubes are stable. No problems with it so far. It's been absolutely fine, but just to be doubly safe before this goes out, because this is a gigging amp, you know, the guys using this for gigs, so we need to make sure it's 100%. Right, on to the demo. We've got this Marshall, we've got it on the 4x12, and it's ready to roll. You see we've got plenty of gain, so we're going to have a bit of a listen. The reason this cable is sticking out of here, because if I push it in, it flicks in the other channel, so that actually works open connection, so I've just been able to push that in there, and we're getting away with that fine. So that'll do just to test both channels. This thing's got an amazing amount of gain, there's so much gain. This Marshall in actual fact is not strange as such, but the coupling caps from the phase inverter to the output tubes are 47 nanofarad, and they're normally 22 on Marshalls. I don't think I've ever seen that before, and you do have to back quite a lot of the bass out, and that's probably why on there. Man, this is loud. Rusty at this style of playing. In fact, I'm very rusty all round.
very rusty. See how much gain I've just flicked into the channel. Those channels are pretty identical really, they're pretty much the same. Rusty. Let's see if we can clean it up a bit then. And it, funnily enough, it does seem to clean up on this channel B better than channel A. So let's just. I don't think many people buy this amp as a clean amp. You're going to use some amount of distortion on it really. And even down at those levels. Very bright amp as well, but not overly so. Too much arthritis in the thumbs. See, that's really nice and bright there, but it's not harsh bright. But you drop a bit of the treble off there and that warms up nicely. Something like that anyway. So there we go. So I've done a mammoth amount of work on this Marshall to get it where it, you know, to where it is now. 30-year-old amp. Had not had a lot of work done to it. What work had been done to it had been not great, but we've managed to sort all that out. It's been a tough one, this, a really tough one, and I've really pushed myself to get this bang on right. Not just for the fact that it needs to be right anyway, but it's a gig, you know, the guy's using it for gigging. We need to make sure this is spot on. So that'll do it for this one. I'm going to put this on the scope now just to make sure that there is no issues, because I can't get this amp up loud enough in here. So it's going on a dummy load. I'm going to put the scope on it, just check it, make sure everything's right. So thanks for watching. You all take care, and I'll see you all in another video. Bye bye for now.